Welcome back to section 5.5 inverse trigonometric functions. Now if you recall, we defined inverse function for those functions which are one-to-one. And what is a one-to-one function? In chapter 2, at the end of chapter 2 in section 2.8 we explained that. So basically, if we have this situation where each element in the domain is being mapped to exactly one element in the range, the second set, so that is a one-to-one function. In the second picture here with this function g of x, we notice that two elements of the domain are being mapped to one element of the range. Okay? So this is not one-to-one. A horizontal line test is also another way to check whether a function is one-to-one or not. So if a function is one-to-one, if and only if no horizontal line intersects its graph more than once. So you can see the first graph here is not one-to-one because horizontal line draw anywhere it will cross at more than 1 points, but in the function on the right is a one-to-one because wherever you draw a horizontal line it only crosses the function mark. So now we are going to talk about inverse trig functions. Well, first is the sine function. So sine function, is it one-to-one? No, because if I draw a horizontal line it will cross infinitely many points, so it is not a one-to-one function. So how can we then talk about defining the inverse? The thing is that inverse trig functions are practically important. So we have to define, and so in order to do that we want to cut a piece of the sine function which is one-to-one and which has all the points of the range. Okay, not the domain, because domain is going to be restricted. We are restricting the domain of the sine function to find an inverse sine function. Okay. So here we are restricting the domain from, so we are taking this piece. So if you notice, domain is from negative pi over 2 to pi over 2 and the range is between negative 1 and 1. So here on this picture is separately given. It should be like this. So it's just this much piece, and it's taking all the domain values are from negative pi over 2 to pi over 2, and the range is negative 1 to 1. Okay, so we say, so we can now define the inverse function, and we denote the inverse function like this. Okay, sine, and we read it like sine inverse x. Okay, we don't read it as sine raised to the power of negative 1 x. We read it sine inverse x. Okay. Or inverse sine x. Okay, so we define it, the inverse sine function, such that we say y will be equal to sine inverse x if and only if. So this symbol, this arrow, like double like this, it means if and only if. Okay, which means it goes both way. When we have just this sign, it means the whatever is written here is implying is giving us that. But in this case, so we have this symbol, so this gives us this and that gives us this. Whenever you see something like this written, so for example k is equal to sine inverse of p, so you can immediately say from here that sine of k equals p, or p equals sine of k. And if you are given something like this, that sine of m equals t, so you can get sine inverse of t equals 1. So that's what it means by if and only if. Okay, so now if you recall from before, from section 2.8, the inverse function, what happens to it, the range of the inverse function is the domain of the actual function, and the domain of the inverse function is the range of the actual function. So in the sine function, remember the domain is on the x-axis, so the domain was negative pi over 2 to pi over 2, but now that will go to y-axis here. So that will become the range of the inverse function, and that restricted domain. And the range of the sine function was negative 1 to 1, which will become the domain of the inverse function, which is negative 1 to 1 on the x-axis here. So this is how we define the inverse. Now this is a warning. As I said, this is not a power. Now recall that we mentioned earlier that if we have something like this, it means sine, you can say sine of x whole square, or it means sine of x times sine of x. Okay? So this is the power here, but when you have negative 1, that is not the power. So why can't we do this? Because we know that if I see the 3 raised to negative 1, we know it is going to be 1 over 3. If we see just like x raised to negative 1, we will say 1 over x. Well, this is about numbers. Okay, numbers we can do that, but here we are not talking about numbers, we are talking about functions. So if you see f inverse of x, it is not going to be 1 over f of x, okay, because this is inverse of a function, not a number. So this property is for numbers. What you have to remember is that the inverse y is equal to sine inverse of x is the number in the interval negative pi over 2 to pi over 2 whose sign is x. As mentioned earlier, so if you see something like this, so from here you can immediately say sine of y equals x. Okay. So here we have example, find the exact value of each expression. So sine inverse of 1/2. So what you have to think about is that we don't know this number. So let's say, say it's equal to x. So then it means sine of x is equal to 1/2. So you have to go back and recall, or you could have called it t, whatever. So what have you learned? The sine of what is 1/2? So x is pi over 6. Okay, sine of pi over 6 is 1/2. The terminal point for pi over 6 is square root of 3 over 2 comma 1/2. So sine is the y value, so sine is 1. Next is arc. Okay, by the way, this is another way of writing the sine inverse function. So this is, I think notation is a little bit better, not confusing, like so we don't have to worry about the warning if we use this notation, arc sine of x. If you see something like this, arc sine of x is equal to y, what this means is that sine of y equals x. That is what you have to remember. Okay, so next thing is arc sine of square root of 2. So you can say, okay, tangent of, arc sine of y or sine of x, whatever, is equal to square root of 2 over 2. So I have to think about a number which gives me this when I take the sine of that number. So now and remember, with these inverse functions there will be only one value, so you are looking in this region between negative pi over 2 to pi over 2. If you look at the unit circle, there will be infinitely many values of x for which this equation is satisfied. Okay? But when we are looking for the inverse function, our domain is restricted, remember. So we are looking for the values in this between negative pi over 2 and pi over 2, including negative pi over 2 and pi. So this will mean x is equal to, or the value of this arc sine of x will be equal to pi over 4. Sine inverse of 0. So it means sine of x is equal to 0. So which value, x value sine is 0? Well, again there are infinitely many, because sine of x is 0. We just saw in the last 5.3, 5.4 video that sine of x is 0 at 0, pi, 2 pi, actually 0 plus minus pi plus minus 2 pi plus infinitely many. But here you have only one answer, and the answer should be here in between negative pi over 2 to pi over 2. So answer will be 0, because 0 is the only value for which sine is 0. Okay, so this was the inverse sine function, and now in the similar fashion, or in a similar way, we will create a inverse cosine function, or the inverse of the cosine function. So we have the same issue here, infinitely many values, horizontal line crosses infinitely many values, so it is not a one-to-one function. So we have to now pick a piece of from this wave, so that it takes up all the range values and it is a one-to-one function. So the piece is going to be from 0 to pi. So this is the piece taken here and drawn separately. So this is the graph of the cosine function between 0 to and pi. But remember, we have now restricted the domain of this cosine function. So this is the cosine function. This is y is equal to cosine x, but x is restricted between 0 and pi. So, and the range is negative 1 to 1. Now we define the cosine inverse function, which we denote by this symbol. Again, warning coming, I think, soon, that this does not mean 1 over cosine. So the domain and range exchange. So the domain of this one becomes the range of the inverse cosine, shown here, 0 to pi on the y-axis, and the range goes to x-axis. So the range becomes the domain of the inverse function. Okay. So now what are we looking at? So if you are asked to evaluate like cosine inverse of a number, so what you have to remember is that you are going to look at this interval, this cosine inverse. So you will have infinitely many values for that number, but you have to pick only one. Okay? Only one value, which is inside this interval. Now for the sine inverse function, we were looking between negative pi over 2 to pi over 2, but in the cosine you will be looking in this region. So what I do, I draw these little graphs with the problem, and that helps me figure out the answer. So for example here, so we are looking at cosine of x equals 1/2. So what is x? So where am I looking for this x? I have to look at for here. So if you recall, cosine of what is 1/2? Pi over 3. So pi over 3. Now this is again, if you can memorize the table of that I showed you in the 5.3, 5. I think before that, in 5.1, 2 showed you bunch of values. Then this becomes easier. Okay, the next thing is arc cosine of square root of 2 over 2. So which means cosine of x equals square root of 2 over 2, and we are looking for that x value there. So since it is positive, so it means it will be in the first quadrant, and what is that t value or the x value? That will be the pi over 4. The next one is cosine inverse is equal to 0. Cosine inverse of 0. So it means we are trying to find the x such that cosine of x is 0, and we have to stay here. So where is cosine 0? At this place, which is pi over 2. Okay, now we will define tangent inverse as well. So again, the same issue, failing the horizontal line test, not 1-to-1. So restrict the domain. So what is the obvious restriction? Pick the middle one. So again, our domain is restricted between negative pi over 2 and pi over 2. But now range is infinite. Range is going from negative infinity to infinity. Okay. So this is the domain, and the range will be negative infinity to infinity. So when in the inverse function, this will become the range and this will become the domain. So this is how we define it. Y is equal to tangent inverse x if and only if tangent of y is equal to x. As I just mentioned, the domain of the inverse sine function is negative pi to pi, and this is open interval, not close. Why? Because we don't have a value at negative pi over 2 and pi over 2. So this is the graph of tangent inverse x. This is again important, especially if you are going to go to Calc 1. Just remember this graph of tangent inverse x, the usual warning, and then values. So tangent inverse of 0. So it means we are trying to find a number x such that tangent of x is equal to 0. So tangent, remember tangent of x is sine x over cosine x. So tangent x is 0 means sine of x is 0, and sine of x is 0 where? At 0. So we'll have our answer will be 0, or x is 0. In this case, the second one, arc tangent square root of 3 over 3. So we are saying tangent of x is equal to square root of 3 over 3. So which one is that? So there are two which use the square root 3's. One is pi over 6 and one is pi over 3. So which one is this one? It will be pi over 3. Okay. Next is tangent inverse of 1. So again, tangent of x is equal to 1. Which angle and you're getting this, you have to have it in here. So it means it will be in the first quadrant because it's positive, tangent is positive, so we get x is equal to pi over 4. Okay, again the same warning that has been mentioned before. Okay, so now I am using the word angle. I had not used the word angle before for those pi over 2, pi over 3, and but now I am using this because this is something you will see that this is a angle, the radian measure of the angle. Okay, this is something you can read on your own, but like don't need to worry about too much. But now we have a bunch of these values that we need to find. Okay, so find the exact value of each expression. Okay, so arc sine of x, arc sine of -1. What does that mean? Sine of x equal to -1, and b must be here. Answer must be in this region. So since this is giving us the sine of x is -1, so what does that mean? It means we will be down here. The angle will be down here, so we have to read it like that. So it will be a negative value. So we get x equals negative pi over 2. Now note here, you will not say, so not 3 pi over 2, okay? You will not say 3 pi over 2, because although this angle here, when we look at it like this, this is the same thing as 3 pi over 2 or negative pi over 2, they are same. But in the case of inverse function, because we said we are going to be in this interval, and 3 pi over 2 is not in there. So you will not read it as 3 pi over 2. Okay? You will read it as negative pi over 2. Similarly, coming to next one, so we are saying sine of x equals negative square root of 3 over 2. So again we have to be in this region. So since it's a negative value, it means the angle is over here. The terminal ray of the angle is in the fourth quadrant. But now what angle? So this will be the pi over 3 one, but with a negative sign. Negative pi over 3. Because we are going to read it clockwise. The next one is sine inverse of 3/2. So in other words, we are saying sine of x equals 3 over 2. Is this possible? Think about it. What is the maximum value that sine of x can have? 1. And what is this value? This is 1.5. So no solution. Okay, the next value, cosine inverse of negative 1/2. So cosine of x equal to 1/2, and we have to be in this. So it's a positive number. 1/2 is a positive number. Oh no, wait a minute, this was a negative. Okay, so cosine inverse of negative 1/2. So cosine of x will be negative 1/2. So where is the angle? Well, because cosine is negative, it means we are in the second quadrant. So it must be an angle somewhere here. What is that angle? 2 pi over 3. Now remember, we always read our angles starting from the positive x-axis and then going in the counterclockwise direction we read them as positive angles, and if we have to go to the clockwise direction we will read them as negative angles. Now is 2 pi over 3 inside this interval? What is this interval? 0 to pi. So yes, it is inside this interval. So let me box my answers. Next one, arc cosine of negative 2. So which means cosine of x is equal to negative 2. So what can you say? Which angle has its cosine equal to negative 2? None. Because the minimum value is negative 1. So this value is out of our out of the domain, so no solution. Next is cosine inverse of negative 1, which means cosine of x equals negative 1, and we have to be here. So again we will be in this quadrant. So the reference angle for this one is the pi over 4. So it means our answer will be negative 3 pi over 4. Okay, notice here we will not have negative pi over 4. Okay, because negative pi over 4 is not in this interval. This interval is 0 to pi. So negative 4 is not in there. So the answer will be 3 pi over 4. Tangent inverse of negative square root of 3. So in other words, tangent of x equals negative square root of 3. So what angle has its tangent equal to square root of 3? And again, where should we be looking? In this region. So this will be negative pi over 3. This means tangent of x equal to negative 1. So answer will be negative pi over 4, because remember we are in this region. Next is tangent inverse of negative square root of 3 over 3. So in this case the angle will be tangent x is equal to negative square root of 3 over 3. So answer will be negative pi over 6. Okay, next. Okay, I think I will stop here, because it might take you guys to try to understand and redo these problems. So I'll continue in the second video.